at least through end of next week of the at the very, very least how we do our generic setups and stuff, it's going to be trig. And as we go through these things, and I was working with Mrs. Thrower and showing her kind of how the book really doesn't do a great job of meandering about through it. And even our old textbook didn't do this great of a job of it as well. And I think over the years we've kind of developed a pretty decent way of making it work, where we kind of just slowly ease ourselves into it and not try to overwhelm ourselves with too much information at once. So a lot of times with the trig stuff that I really, really like to do is make it as generic as possible. Because if you do the exact same process over and over again, which we've been trying to instill in you guys with the 30-60-90s, the 45-45-90s by writing those out and all that, if we instill that exact same process to master that, everything else is easy. But if you're not writing out your steps, if you're not filling in the blanks, if you're not making all that work, it doesn't matter if you just write a bunch of numbers on a homework sheet and think that I'm going to realize it's what you were doing, or just writing out your ratios and not solving it, which a lot of you guys do also. You're just shooting yourself in the foot, because when it comes time to put pen to paper on a quiz and stuff like that, that's when you have to show that you can do it. Okay. So when we talk about this idea of what's called trigonometry, is that not always are you going to have triangles that you know how to work with. What I mean by that is not always are you going to have 30-60-90s or 45-45-90s. Or you're not always going to have two sides. Because remember, when you have two sides of a right triangle, you can always fall back on Pythagorean theorem. That never changes. Pythagorean theorem will always, always, always work. But you'll still see us use it from time to time with this as well, because sometimes it's the quickest. But what happens here is that we talk about this thing called trigonometry. And the way that I've always thought about it is trigonometry to me has always been about what we call like a perspective. And what I mean by that is, where are you in relation to the in the triangle as far as what information you have and what information you're looking for. So what I like to start with these things is to kind of run through an idea of how you take a triangle and label. So let's do this. Let's draw a right triangle to start with and go off of that. So we take a right triangle. And for this example here, I don't even know what section this is. It's like 8 something, 3, 4. Yeah, I think it's 8, 4, or 3. I don't know. It's somewhere in the middle of chapter 8. I don't recall the exact number of it because I don't like numbers, because I'm going to kind of meander through a bunch of different stuff at the same time at a sequence that I know makes sense for you guys. Okay, it may sound weird, but this is Thrower and I, it's the first day, so we kind of have an idea of how your brains work. Small amount, not a lot. Some of you guys are just really weird. Yeah. Anyway, so here's what we have. We've got a right triangle. What is the one thing that you always know is located? The 90-degree angle. Also, what's always across from it? Does the hypotenuse ever change? No. The hypotenuse is always constant. It's always relied upon. You always know where the hypotenuse is. That never changes. Now, what's going to happen here today is that you're going to have side lengths, and you're going to have one of the two angles. For example, if I say this is 37 degrees, I can't use my special right triangles. I can't use those things to get to anything. But I know that if it gives me a picture and I have an angle, what I'm always, always, always going to do, I'm going to circle my angle, and I'm going to draw an arrow to the side opposite. Okay. I'm going to draw an arrow to the side opposite. Now, when we're dealing with trigonometry, we're talking about what's called right triangle trig. When we have right triangle trig, there's only going to be 3 sides to worry about. You're going to have the hypotenuse. You're going to have the hypotenuse, an opposite, and what's called an adjacent. Okay. you're going to have what's called a hypotenuse, an opposite, and an adjacent sides in the right triangles. That will never, ever, ever change. By doing these first two, by circling where you are located and drawing an arrow to what you are looking at, that is always going to be the side opposite you, is always going to be the side that you are looking at when you're at that angle. So that by process of elimination, what is left for that last part? This last part, the last side, I should say, that would have to be called the adjacent. And we abbreviate it with ADJ. Okay. So when I'm looking at these things, what we're doing here is that in trigonometry is nothing but a whole bunch of what are called ratios of the sides. And the ratios of the sides are dependent upon the angle measures. You guys all agree that angle measures, as angles get larger, sides across get larger? But then it also, if there's another angle going the other way, if this 37 degree gets larger, this angle up here is going to do what? It's going to get smaller. It's going to get smaller. If this gets larger, that has to get smaller because you're right about that then. So the angle up top here would get smaller, which means this side opposite would get larger. This side here would get smaller. Are we okay with that? That's how the fluctuations in the side lengths go. And we dealt with that back in chapter where we said that the larger angle had the larger side, the smaller angle, the smaller side. It's the same basic principle here. So as you go through these things, we're going to talk about what are called trigonometric ratios. And they sound really, really weird, but yet you've been looking at them forever since you've had a calculator. Those mysterious buttons on the calculator say SIN, COS, and TAN. They stand for specific trig ratios. We have what are called sine, cosine, and tangent, otherwise known as sine, cosine, and tangent. Those are going to be what are called the three trig ratios that we use in geometry. Okay. Excuse me. And depending upon what information you know, is for what information that which one of these guys you're going to use. Now, basically over the course of the next, 2-3 days or so, we are not even going to bother pressing buttons in the calculator until we're ready to write everything out. Mrs. Thrower, no, we're not going to use the calculator until next week. Because when Mrs. Thrower and I were talking about this, is that, and you guys have all seen this. You know how sometimes you don't write out all your steps or anything like that, you just press buttons in a calculator. If we don't know what you did, we don't know what button you did, what button you accidentally pressed. So there's no way for us knowing that, oh yeah, I knew that it was 3 divided by 7 and add 4, whatever, but you could have typed in 3 divided by 8, and if you don't show the work, we won't know what you did. In this section especially, it's super important to be able to write down what exactly you are doing. Because there's going to be times in the calculator that you're going to actually have to type in, don't worry about writing this down, you're going to have to type that into your calculator. And if you don't type that into your calculator correctly, it is so easy to screw up. Especially if you look at your calculator. When you look at your calculator, see how you have that sine, cosine, and tangent button right next to each other? A lot of times if you don't accidentally, when you hit a cosine, what happens? What opens up automatically? Parentheses. So if you don't close a parentheses, you can get an incorrect answer. If you hit the wrong button, you get a wrong answer. If you hit, instead of 23, if you accidentally hit 26 as you're typing things through. It is so easy to mistakenly press a wrong button. That's why I don't even bother using the calculator for at least a week until we get that done. So what we're going to work on is how do we get to this before we press buttons? Because we're going to ask that you guys always show what you're going to write into the calculator, or type into the calculator, excuse me, before you type into the calculator. Because it forces well, I shouldn't say it forces, it helps you to slow down, which I know some of you guys tend to like, just get this over with. But it also helps us backtrack because it's so, if you wrote down 23 cosine 74 over 18 and you typed it in incorrectly, you got it the wrong decimal, I would be able to backtrack and figure out that you typed 19 or 17. It's much easier on us to figure out where you went wrong by typing the wrong number. And Lord knows you guys can't read your own handwriting sometimes. 5s look like 2s and stuff like that, right? It happens. So that's why we're trying over the next few days. If you don't have your calculator in class, fine, not a big deal. I know I'm actually saying that because it's really not a big deal because we're going to just focus solely and you write it out to get to your calculator. Okay? Does that make sense? All right. Now, when we get to these things, it's a matter of which one are you going to use. And they have these, the way that the ratios of the sides work is that each angle has its own set of values for the ratios of either sine, cosine, or tangent. And those ratios are dependent upon their sides that are opposite, sides that are adjacent, or the sides that are the hypotenuse. So each trig function could work for any problem dependent upon what information you have. And that's where it boils back to. Okay. So the three functions work like this. If you want to look at, and I'm going to use a different symbol for an angle. You guys ever seen that before? That stands for theta. Sine of theta is the same thing as saying sine of an angle. What we do here is we use this theta symbol as more common as you get higher up in math. So you'll see this theta symbol a lot more. It just stands for an angle. Okay? Yes, sir.
I don't know why, but I keep thinking of that.
It kind of looks like it. Yeah. It kind of has that look. So when we have right triangles, let me draw this back out here. If I put an angle here, that angle always looks at its opposite, which makes this side its adjacent, because this is always your hypotenuse. Are we okay with that? So the sine of any angle is always going to be equal to the side opposite divided by its hypotenuse. So if I'm going to use that sine figure, that means I'd have to know the value of the angle, the value of the side opposite, and the value of a hypotenuse. And as we draw into a couple examples, you guys will see how quick this really is. Okay? The cosine of an angle is always the value of its adjacent side and the hypotenuse, over the hypotenuse. And then the last one is tangent. It's your opposite over adjacent. So if I'm looking at just those values, notice how two of them use a hypotenuse and one of them does not. Everybody see that? So a lot of times when you do this, if you know your hypotenuse, you know you won't use tangent. Okay? If you don't know your hypotenuse, you have to use tangent. So it kind of helps whittle down for what function you're going to wind up using. Okay? And it all goes from drawing from where you're at. So when we do these, let me write this on the other board here. You might come up with a moniker.
Yeah. Don't pronounce that thing, you guys.
It's not a 9 Inch Nails song.
It's not. It is song.
It's a song.
Okay.
Pretty Hate Machine, track number 5.
Oh my gosh.
1988.
Wow, this was good.
Yeah, I'm a bit of a moron when it comes to music. In case you didn't know that. You guys have all heard the story of the proud people of the Sokotoans. No, seriously. The Sokotoans. the Sokotoans, they were a tribe they preceded the Greeks in a lot of math stuff. What they did was they were measuring out their fields. And you know how when you have your cornfields and all stuff, usually everything's all squared out and everything like that? Well, they were trying to figure out ways of measuring out other distances and stuff given angles. Because you knew way back in the day, they were able to use, have you ever seen like a sundial? You guys know what a sundial is? You know what a sundial is? Really? All right. So a sundial, picture this. Let me steal this for a second. Sundial is you take something that, a little vertical thing that's like you put it as a clock, and you place it so it's facing north. Okay? As the sun, it's dependent upon how the sun is over it, the shadow line tells you times. So shadow lines and stuff like that also were used for, they would use that along with other math, if you will, to measure angles. That's how they were able to. You guys ever seen in old pirate movies or ship movies where they've got the little micrometer? It's a, what's it called? It's not a micrometer. We make them. Used for angle, elevation, depression. Anyway, a surveying equipment. You guys ever see a guy with a tripod sitting out there and he's looking through the machine, and there's another guy about 200 feet away with a pole? They're using lasers to measure angles of elevation and depression. So way back when, they used to use stars. It was how they navigated. They measured angles out like that. Well, they figured out that by using angles and stuff, they were able to measure distances via square, off of a square angle. So they're able to figure out other distances out that way. So the Sokotoa tribe, they had to develop ways of remembering how things worked. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. So how they make this stuff up? Tangent was opposite over adjacent. So they used their name to say, hey, let's make up these trig functions, or however they pronounced it back then, and used them. And it stuck. And then the Greeks stole it, and they put this theta in it, and they say, hey, this is... Well, I mean, Greeks ran, Euclid was there, and Pythagoras was like, hey, they might have something for this. You never know. So you get this silly moniker of it that it's the easy way to remember what you're dealing with. And you're able to do that. It's a cheesy way to remember it, but if you think of the proud Indian tribes measuring their cornfield or their maize fields, yeah, multicultural.
At the end of the class, before the dollars, promise me you're going to Google this guy on YouTube. Just Google the Sokotoa song. It's about a minute and a half long, but he does it's like over 17 million views of this guy. So you can laugh all you want, but I want you to watch it. At least play it for the last few minutes of class.
Hyped it up, right? You gotta do it now.
Make your own song. Yeah, right? Well,
oh man. So let's do this. So I don't know. Let's start with something like this. Oh, I don't want to. Sorry. And this is kind of what it's going to look like to start. You get a right triangle. You're going to have one side length known. You're going to have to find the other side length given a specific angle. So like we did this earlier. We talked about this earlier. Step number 1. Circle the angle, or theta. Okay. So if we circle the angle, draw to the opposite. So the second step would be draw to the opposite side. We had this stuck in my head, thanks. And label it. So if I'm drawn to the opposite, what is that value of x going to be called? What side is it? Careful, I'm drawing to the opposite, so that is my opposite. So here's my opposite. Label your hypotenuse. Which one's the hypotenuse? 7. Now, label your adjacent. Which trig function would you have to use if you're looking at an opposite and you have a hypotenuse? Which one uses opposites and hypotenuse? Sine. What's that, Josh? Oh, we don't have to. Because what we're going to be able to do is, like we were talking about earlier, we're going to be able to solve for missing side lengths knowing an angle and one side length. Well, in this case, which two sides am I working with? In this case, I'm working with the opposite and the hypotenuse. So which trig would be my next step? Is it sine? So we have let me write it this way. Since we know we have a hypotenuse value given to us, we know it's not going to be tangent. So then it's just a matter of, am I going to be using sine or am I using cosine? Well, I'm looking to find my opposite. So which one of those two uses opposites, sine or cosine? Sine. So that tells me then that I'm going to use the sine. So I have the sine of my angle is the opposite over the hypotenuse, which was it 27? Okay. And then honestly, for each of these types of problems today, there's only two ways that you're going to have a value of x. You're either going to, bless you, you're either going to have x in a numerator or x in a denominator, bless you. And every time, we're going to do one of two ways to solve it. Real quick, before we get too much further here, I just want you to take your calculator out real quick. And I want you just to press the button, sine 37, close the parenthesis, enter. And I want you to see this, just what it is. 0.6 something in a bunch. It's just some crummy decimal, right? You guys okay with that? It's just a crummy decimal. And it's not going to square root anything. It's not going to do anything like that for you at all. It's just some crummy decimal. So what I want you to think of here is that instead of getting the crummy decimal and rewriting crummy decimal all the time, we're going to use sine of 37. We're just going to say that's what it is. Now, on the other side of the equation, you've got x divided by 27. How do you undo divide by 27? Multiply both sides by 27. So to get x by itself in this case, you get 27 times the sine 37 is x. And that's our answer for today. That's going to be our answer. Now, what happens here is that, like I was saying a second ago, there's only two ways to solve these problems. Today we're dealing with side lengths. You're either going to have an unknown in the numerator or an unknown in the denominator. I'm going to show you how that works itself up going either way real quick. So if you have, we'll say trig of theta, what I'm abbreviating this as, it can be sine, cosine, or tangent. So trig of whatever is going to equal x over a number or trig of some angle is some number over x. So our variable is either going to be in the numerator or the denominator. So thinking about what we just did an example where x was the numerator. In order to solve for it, we multiplied both sides by the denominator, right? So in my generic way of solving this equation, it wound up being some number times the trig of an angle was the answer. Whereas the other one's a little bit different. When you have something in the denominator, we've done this before with a shortcut. If I put that over 1, does it change anything?
No.
It becomes fraction equal fraction, doesn't it? And when you have fraction equal fraction, you had ratios. And what do we do on diagonals of a ratio all the time?
Cross multiply.
We didn't cross multiply. You can't cross multiply to solve it out. But remember how we did exchange-o, change-o? Remember how we did this over and over again? Remember I wrote 2/3 equals 4/6, and we exchanged them. You said 2 over 4 was the same thing as 3 over 6, just by switching them on the diagonals. That's what you do here. Anytime you have a fraction equal fraction, and your unknown is in the denominator, you're always, you do an exchange-o, change-o. You're not wrong by saying cross multiply, because you would multiply the other one by x, and then you divide it by trig. It's just taking the long step through it. But if you remember fraction equal fraction, just exchange-o, change it. You get x will equal, you'll get something like that. You okay with that? Excuse me, we'll write that down too. A lot of little shortcuts we're going to see over the next few days. Do one more before I do the sheet that has all the rest of the examples of it. First step, circle your angle. What angle do we have here? All right. So I circle my 44. I draw, as the second step, I draw and label the side opposite. Do I have any numbers or any variables for the opposite? So that means right away, am I going to use anything with an opposite? So if you think about it, that means I'm not going to use sine, and I'm not going to use tangent because they both use opposites. So this is going to be a cosine problem, isn't it? You can tell right away because you're not using an opposite. So I label as my next step my hypotenuse. And then I have my adjacent. That tells me I'm going to have to use cosine because I have an adjacent and I'm trying to find out a hypotenuse. The cosine of something is the adjacent divided by the hypotenuse. Well, what's the angle that we're working with? 44. And what's the adjacent value? What's the hypotenuse value? X. Okay, now you substitute in. So you get the cosine of 44 is 3 over x. Which of the two setups is it? Is it number over x, or is it x over a number? Number over x, what do you do? According to our little cheat sheet, what do we do? Flipperoonie, exchange or change. Close enough. We do the exchange-o change-o on that. We do the exchange-o change-o, I'm going to get x is 3 divided by the cosine of 44. And that's my answer for today. What I did here is I made, instead of having you guys constantly redrawing triangles, I just made a copy of a whole bunch of triangles. We're just going to work through draw, setups, and solves. Draw, setups, and solves before we even press a button on anything. Because that's the easiest way to make sure we set these things through. Sorry I didn't start at 1. I'm looking at 13 to start with here. What's your first step? Circle the angle. So the first thing I do is circle the angle. My angle that I have here is the 27. The second step is to draw and label to the opposite side. Well, the opposite side is there. Is there any information there? There's no information there, which means I know I'm not going to use sine, and I know I'm not going to use tangent. You start processing that this way. The next step is to label your hypotenuse. Next step is to label your adjacent. And then you figure out what trig function you have. Well, we don't have an opposite. We have a hypotenuse, and we're looking for an adjacent. That means I'm going to use cosine. So, suggestion. On every time for the next, probably the next week, on every top of sheet of paper or anything you get, write that down. That way you remember what values they are. So we know that we have to use cosine again. Cosine. Cosine is forgot to write down what it was first. Cosine of an angle is adjacent over hypotenuse. So we have our adjacent is the unknown. Hypotenuse is 13. And you go back to the idea here, where's your variable? Is it the numerator or denominator? So how do I move the denominator? Just multiply. That's why we have those little tricks up there. And you go to the next one. Okay. There's only one of two ways to solve that equation. You either exchange-o, change-o, or you multiply by a denominator. It's the only two ways to make it work. And that's what's nice about these things. There's not a lot of having to worry about a lot of different mathing, if you will. Right. Not pressing buttons, not doing anything at all. We're just doing the setups. Because if you get this far, the button stuff is easy, but just getting this far. All right, what's your next step? What's your first step on 14? You said, Josh, what is it? Circle the angle. Okay, so if we circle the angle, that's my step 1. What's my next step? Sorry, standing what? Draw to the opposite and label it. Do I have any info for the opposite? No. don't have information, so you know right away, again, am I going to be using sine or am I going to be using tangent? Nope, because there's no opposite given. Label, hypotenuse. By process of elimination, the last side is going to be the adjacent. So you're going to have to use cosine again. And by having everything labeled, you really can't screw up where you put stuff. That's the idea. The more you label, the more stuff you put down on paper, the easier everything else becomes because you know where the adjacent is. Well, the adjacent goes to the numerator. You know where the hypotenuse goes. Oh, the hypotenuse goes in the denominator. It tells you specifically where things have to go. It forces you to fill in the blanks correctly. Okay. The variables in the denominator. What do we do to solve that? Remember, there's only one of two ways to do it. Change them, change them. And you leave it. You just leave it. We're not trying to hit buttons. We're not trying to do anything like that yet. We'll get there. It's not a big deal. I'm sorry, what was that? No, that's not, remember, since this is the denominator, that's the exchange of changeover. Okay. Do you have that on here? No. No. Make sure you write that down. It's over, remember, there's only one of two ways to solve the trig. It was one of those. Make sure you get that down. That is super important to have. Okay. There's only one of two ways to solve it. Either if it's in your unknown is in the numerator or the unknown is in the denominator. And this is going to work every time next. This is always going to work. It's a little different when we have to solve angles, but that's a whole other worry about. What's going to be your first step in 15 then? Circle the angle, then you draw to its good. Get this out here so you guys can see it on this side as well real quick. All right. So let's redraw this one here. We have you guys noticing how they move the triangles pretty regularly? They flip-flop sides, they flip angles, they rotate stuff around. They do that on purpose because not every right triangle is going to be, oh, the right angle is on the right-hand side, and you got all the other stuff. They do that, and by following these steps, it all works out the same. It doesn't matter. First thing you do, just like Shai said, circle your angle. Second step, draw and label the side opposite. It's kind of hard to mess that up when you know the angle is looking at the side that it creates. There's your opposite. Third thing you do is you label your hypotenuse. Well, the hypotenuse never changes. It's always across from the 90. Third thing you do is you label the last side, which is the adjacent. In this example, you don't have any information about your hypotenuse, which means you cannot use sine or cosine. So what do you have to use? Tangent. This one means you have to use tangent, so it's the tangent of your angle is your opposite over the adjacent. So filling that in, you're going to get tangent 49 is x over 18. Now remember, these buttons that say sine, cosine, and tangent, they're completely irrelevant for us right now. It just means that that angle has a fraction that will be equal to this x over 18. You just got to figure out what that value of x is. So in order to do that, since the x is the numerator, we multiply out. We do that. You're done. We're not pressing any buttons. Okay. Now, let's see here. Take a minute and do 16. We'll check it, and we might just finish these out for the rest of these last 6 or so for setups for tonight. We'll continue with this tomorrow, obviously. It takes a while to go through. We take a nice, slow start to this, so we got plenty of time. It's not terrible, is it? If you follow these steps, guys, it's the easiest way to do it. So if you don't have these steps written down on your sheet, write them on your sheet. If you don't have the generic setups for the trig, write it down on your sheet. If you don't have SOHCAHTOA written down, write it down. The more information you have in front of you, the easier all this stuff becomes. Oh, let me draw it real quick. We'll check before we get out of here. I know we're running out of time here, so let's just go through this real quick. First step, circle the angle. Next thing, draw to the side opposite and label it. Then go to your tangent. I'm sorry, go to your hypotenuse. Process of elimination. What trig function do you have to use for that one? Sine, very good. You know you have to use sine because you have an opposite, you're looking for a hypotenuse. So, write out sine of something is the opposite over the hypotenuse. So, sine of 27 is 13 over x. Very good. X will equal 13 divided by the sine of 27. So, you've got what? 8 more of these? Write out all your steps. Label everything. Go through that. Ladies and gentlemen, I cannot tell you how important it is to just slow down and follow that procedural stuff. I know math kind of sucks when it's procedural, but there are times that when you do it this way, it's so hard to screw up. Okay? I'm trying to make this almost kind of like foolproof. I hope. All right? Oh,